would like you to draw two triangles that appear to be congruent on your paper. I'm going to do the same.
Bless you.
To prove that triangle ABC is congruent to triangle DEF, what things have to be true? We'll say, and how many? Ain't somebody tell me one statement that has to be true for those two triangles to be congruent. What does congruent mean? Same what? Size and
Shape.
shape. Right now, what would you have to say is true? You guys remember something called CP/CTC? Corresponding parts of congruent triangles are always congruent. Now, remember we talked about that when things are congruent, they're the same size and shape. What determines their size? No, that determines their shape. What determines their size?
Length.
The sides, length of the sides. So we can start with the shape if you want to start with angles. What angles would have to be congruent for this to be congruent to this? Angle A would have to be congruent to what? Okay, so that's one thing we'd have to prove. Angle A would have to be congruent to angle D. Anything else? Huh? Angle B would have to be congruent to angle what? Is everybody okay with that? But that wouldn't be enough because that's only two things, isn't it? There's a lot more things that are true if two triangles are congruent. So we have to keep going. What would be another one? Angle C would have to be congruent to what? No shortcuts or anything that still isn't enough. All I've taken care of is that they're the same what? Shape. Now I need to take care of that they're the same what? Size. I've taken care of the angles. Now I need to talk about the what? It's not a line. All lines are congruent. Say it again. Segment, side or segment. AB is congruent to segment what? So AB would have to be congruent to DE. Now we're at four things. But are there more sides and stuff that have to be congruent for them to be congruent?
Yeah.
What one?
AC.
Oh, I went with BC. Is that okay?
Oh, yeah.
BC has got to be congruent to
EF.
Yeah.
everybody see that? And what's the last thing?
CA.
AC has to be congruent to what?
DF.
How many different things are there? 6 things. That's a lot to prove that 2 triangles are congruent. Wouldn't you agree? What we're going to talk about to finish up this chapter, okay, are shortcuts to proving 2 triangles congruent. Where we don't have to prove 6 things. Right now, the information you've been given so far, you have to prove 6 things. In the rest of this chapter, we're going to talk about 4 theorems that allow you to only have to prove 3 things. If you prove these certain things congruent, you can say the 2 triangles are what? Congruent. Okay? There are going to be 4 theorems of that. 4 shortcuts. The first one. Is labeled like this, SSS. The reason it's labeled like that is because it represents side, side, side. One of the first things I told you is that mathematicians are lazy, so we want to have little shortcuts or little short ways to write things. They don't want to have to write out side, side, side each time, so they decided to call it what? SSS. What it says, if you have 2 triangles whose three sets of corresponding sides are congruent, then the 2 triangles have to be congruent as well. So here, see how we cut it down to 3? Basically, if you could prove what on this list? 4, 5, and 6, you prove what? The 2 triangles are what? Congruent. A lot of people do much better with this if they visualize it by drawing 2 triangles underneath this and labeling them with the marks. What would side, side, side look like? Well, this would be congruent to that. This would be congruent to what? That. And this side would be congruent to that. These 2 triangles are congruent by what? Side, side, side. So you don't have to prove all 6 things, do you? If you can find that all 3 sides are congruent in each triangle, that this, this side, you understand what we mean by corresponding? Any questions there? What I mean is that this one corresponds with this one and they're what? Congruent. This side corresponds with this one and they're also what? Congruent. This side corresponds with this one and they're what? Congruent. So everything we're going to do here is we're going to be comparing 2 triangles. So in each set we're going to have to talk about the sides that correspond. Okay? So your first big shortcut is what? SSS. So any time that I prove that 2 sides are congruent, all 3 sets of sides are congruent. Now, let's do an example. And this is the most common one you'll see, even though I didn't draw it very well. triangle ABC congruent to triangle ADC? And why? If so, why? Did anyone answer that question? Court, what do you think, Bob? Is triangle ABC congruent to triangle ADC? If so, why? Anybody else? Okay, looking at this. So far, all I've got is side, 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 right? Well, I'm going to label them, how about we label them S1, S2, and S3? Okay? Is there one set of sides congruent? Those, that one and that one, isn't it?
Mm-hmm.
How about this one? So I have two sets of sides congruent. So I've got the S and I've got the S. Do I have a third S? I don't have one labeled. But what I want you to look at and realize I'm talking about the two smaller triangles, am I not? What about AC?
There's nothing congruent to it.
But here's the thing. Is AC a part of this triangle? The triangle on the left?
Yes.
But is AC also a part of the triangle on the right?
Yes.
Wouldn't AC have to be congruent to AC? What this is called is it's called a common side. Because they have this side in common, don't they? AC is a side of the triangle on the left, and AC is a side of the triangle on the right. Agreed? So actually it ends up being our S3, doesn't it? That's one of the ways they'll try to have a problem where they don't label that the third side's congruent, but you need to be able to look at it and see that, hey, they have a common side, so of course they're congruent to itself. So the answer is yes, it is congruent by what? Side, 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 congruency. That's how you would answer that. Because they have three sets of sides congruent, do they not? And ones like this that are labeled with all three sides congruent will be easy. They might also try to have some problems like this. Would these two be congruent right here? You don't necessarily have to write this down, just watch. Would these two be congruent right here? Well, this side that's 15 long would be congruent to the other side that's 15, wouldn't it? This side that's 5 units long would be congruent to the other side that's what?
5.
And that one's congruent to that one, isn't it? So they are congruent by what? Side, side, side. Side, side, side's the easy one. You guys got that? Okay. Now, the harder one. Shortcut number 2. We'll have 4 total, spread out over 2 sections. But this is probably the hardest one. SAS. And the order in which they write these is very important. And this one, and you need to pay attention, you're going to be in trouble. Side, angle, side. Everybody both hands on the desk to make sure you're staying awake. I know you had 5 days off, you slept in, you stayed up late. You're having problems staying awake right now, so I want to see everybody's eyes. That's you too, Corey. Hands down so I can see if you're awake. Good man. Hey. Okay. Side, angle, side. Okay, this one's going to sound weird to you. If two sets of corresponding sides are congruent and the angle included by those two sides is congruent, then the two triangles are congruent. People have a problem with this probably because of this word and because the definitions itself is very wordy, but there's really no other way to write it properly. This is one of those ones where the picture helps you more than anything. First of all, let's talk about the word included. I think you need to think of included in geometry as basically meaning in between. Included equals in between. Probably some complicated reason why they couldn't use the word in between. So it's basically, so what's going to happen here is in this, what's going to matter is the two sides that are congruent. And I'll give you an example. We'll draw yourself two triangles. Okay, everybody pay attention and don't write. This is important. Okay. Side angle side. Let's say that AB was congruent to DE. And AC was congruent to DF. Okay, we've got two of the three. We've got two sides, don't we? Now, I want you to ask yourself, which angle, in this case, you've got two sides congruent, right? And the key to this is, even though we're talking about two triangles, you need to think of one triangle at a time. So let's think about the one on the left. We've got two sides that we've marked as being congruent to the ones on the other side, right? Which one is the included angle? Now, remember I said in between. So, which one looks to be in between the two marks? Does it look like A? That's what I would infer. But at the same time, let's investigate it a little bit further. And here's the way, another way you can get included. This, I'm going to draw the side congruent, right? When I draw the other side congruent, what angle did I draw? What angle changed to red right there? That's the included side. It always works that way. So if every time you trace over the two sides that have the marks on it that are congruent, You'll always draw an angle, and the angle you'll draw will be the what? The included what? Angle. So look over here. Which angle would be the included angle? Well, let's say, even though you may be able to see it, draw the two sides. Okay, this is one of my congruent sides, correct? I just drew it, and then I draw the other one. Which angle did I just draw? That's side angle side. There is a reason that they put the A in between the two S's. You know why? Because the included angle is the one what? In between the two what? Sides. So we're going to do some examples. Side angle side or not side angle side? And you guys don't have to write this down. You can look at it online. So we can do this fast. I am going to draw a bunch of different triangles. And I want you to tell me whether it's side angle side or not side angle side. And of course I haven't labeled anything yet, have I? So obviously none of them are side angle side yet, are they? Okay. Now, here's the deal, guys. You have to look at both of them. Basically, you've got to look at this one. On the left, is it side angle side here? It's obvious in each of these two I have two sides and a what? Angle. I have the three parts I need, but is it the right three parts? Okay, here, I have a side. Two sides, right? Draw those two sides. Do I make the angle that's congruent? So is this one side angle side?
Yes.
Okay. But both of them have to be side angle sides. So you got to make sure this one is too. I've got two sides congruent, correct?
Yes.
Draw the two sides congruent. Do I draw the angle that's congruent?
Yes.
So I have side angle side for both, so they are congruent by what? Here I have side angle side. Easy enough?
Yes.
Go on to the next one. Look at the one over here on the left. I need to see everybody's eyes. Come on. Hands down. Sit up. Hands down. How do I know? Do I have side angle side here? I'm going to draw the two sides that are congruent with my pen. Did I draw this third angle? Huh? Did I draw the angle congruent? So I have side angle side here. Here, I have the three types of things I need, do I not? So I'm going to draw the two sides that are congruent. Did I draw the angle? So here I have no side angle side. So are these two congruent?
No.
So this is not what?
Congruent.
See the difference? I had side angle side over here, but I didn't what?
Over there.
Over here. Do I have side angle side here? When I draw the two congruent sides, did I draw the angle congruent?
Yes.
So I have side angle side here. Do I have side angle side here?
Yes.
Yes.
So are they congruent?
Yes.
So I have side angle side. Do Do I have side angle side here?
No.
No SAS, right? Do I need to go on any further?
No.
Not side angle side. Do I have side angle side here?
Yes.
Do I have side angle side here?
No.
I
Oh,
do, don't I?
yes.
Draw the two sides. Do they draw the angle that's congruent?
Yes.
So they are congruent by what? Right here. Do I have, well, I haven't drawn anything yet, have I?
Not sir.
Do I have side angle side here?
No.
As I draw these two sides, do I draw that third one?
No.
No, so no side angle side. I don't need to go on any further, but this one's no side angle side either. Isn't it kind of obvious once you look at it for a while, when they're not in between them? You can kind of see it, can't you? Okay. Everybody get out that worksheet. Did the worksheets ever make it back to me?
Yep.
First of all, on top of this sheet of paper, can anybody remind me what happens in this situation? What is that called? What do we know about the opposite angles?
They're always congruent.
They're always congruent. So is that something you can look at a picture and know is true? So let's look at number one. Tell whether these two triangles are congruent. Write the congruency statement and explain why. Do I have three things? My only possibilities here are side, 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 or what? Side, angle, side. Okay, what things do I have? I have an S, I have an A, and I have an S over here, correct? Here I have a what? S and an A and an S. Does that mean I necessarily have side angle side? No. No, it doesn't. I have to make sure it's the right angle, don't I? If I drew this side and that side, am I drawing the angle congruent? If I drew this side and that side, am I drawing the angle congruent? So they are congruent by what? Side, angle, side. But you need to write a proper congruency statement. Triangle, I'm going to call this LKN. Is congruent to triangle. Well, what order would need to be in the other one? If I did LKN, I would need to write what? LMN by side angle side. Would you have been wrong to have said because that's a common side, they're now congruent by side, side, side? No, you wouldn't, would you? Because they had a common side too, didn't they? Number two, I have three things here, don't I? I have an S, an A, and an S. Well, is this one side angle side?
Yes.
Is this side angle side?
No.
The angle's outside the other two, isn't it? It's not in between. So are these congruent?
No.
Not congruent. Everybody see that? Going on to here. Is this one of the easy ones?
Mm-hmm.
What do I have here?
Side, side, side.
Side, side, side's easy to recognize, isn't it? So triangle, now here's the only problem you can get in writing a proper congruency statement. Okay, I went from Y to Z. Here's one thing you can do. I drew the 1 mark, didn't I? So I need to draw the 1 mark over here. And I started with Y, it was connected to the 1 mark and the what? 2 mark. Which one's connected to the mark one, the one that's marked once and the one that's marked twice? Huh? V. So I have to go V first, then U, and then T. But on ones like this, it's really hard, because by looks, if you were just looking at the triangle, don't U and V look to be almost the exact same size?
What's the
So the only thing I could go by, as far as corresponding, is that Y connects the one with one mark and the one with what? 2 marks. So I looked over here,
Hey, 2 more.
V is the one that connects the one with what? 1 mark and the one with what? 2 marks. And then by what? Side, side, side. Number 4, real quick. Is this side angle side?
Yeah.
Number 5. As it looks right now, is this side angle side?
No.
However, are the 2 triangles congruent?
Yes.
Mm-hmm.
Yes.
No, they
Can anybody tell me why?
Because it has a vertical.
These vertical angles right here, this one is congruent to what? Is that not
Now.
true?
Mm-hmm.
I just thought they looked the same.
Only 2 on that one.
So, but do I have congruent triangles even yet? Do I have side angle sides yet? No. But if these 2 are congruent, wouldn't the same amount left out of 180 have to be left for this one? So wouldn't these 2 then have to be what? Congruent? Now do you have side angle side?
Thank you.
I'm gonna go MNO is congruent to triangle. I went from 1 mark to 2 mark to 3 marks, so PQO. That one was kinda tough. I think they mismarked this if you wanna know the absolute truth.
Yeah. That's not supposed to.
But our logic there is sound. They have to be congruent. Now, if you look at this one, is this one pretty easy?
Mm-hmm.
Yeah.
What is it? Congruency statement though, can you guys write it in corresponding order?
FTV.
What's your first triangle?
WZY.
If you go WZY, you then have to go what?
X, Y, W.
Nope, YXW.
Okay.
Because the Y corresponds to the W, doesn't it? It's the point up top.